In this video, we're going to be looking at how to do matrix arithmetic, which includes multiplying by a scalar multiple, as well as adding and subtracting matrices. The first thing we're going to do is we have two matrices here at the top. We have matrix A and we have matrix B. We need to work out the dimensions of A and B. To work out the dimensions of any matrix, we simply work out how many rows there are and how many columns there are. For matrix A, we notice that we have two columns and also two rows. So these are your columns and these are your rows. So two columns, two rows, so we would write that as a 2 by 2 matrix. And what we also notice is matrix B has the exact same dimensions. Because we have two rows followed by two columns, it's going to be a 2 by 2 matrix. You can only add and subtract matrices that have the same dimensions. That is the only thing we need to know for questions 3 and 4. To multiply any matrix by a scalar multiple, let's say k times the matrix A, all we have to do is we have to multiply every single element in a matrix by the constant k. So let's have a look at question number 1. What is the value of 2a? To work out the value of 2a, all we simply have to do is do 2 times the matrix of A, which is 3, 2, minus 2, minus 2. To work out the value of 2a, we're simply going to times each element inside this matrix by the number 2. So what we'll have is 6, 4, negative 4, and negative 4. That is your answer to question number 1. What about question number 2? Should be pretty straightforward. All you have to do is do 3 times by the matrix B, which in this case is 0, negative 3, 4, and 1. Timesing 3 to all of the elements in this matrix, what we end up having is 3 times 0 is 0, 3 times minus 3 is minus 9, 3 times 4 is 12, and 3 times 1 is 3. And this is your answer to question 2. Question 3. How do we add two matrices? Well, we can only add two matrices if they are the same dimensions. So matrix 1 here, in this case matrix A, is 3, 2, negative 2, negative 2. And we're going to add that with matrix 0, negative 3, 4, 1. What we notice here is this is a 2 by 2 matrix, and this is a 2 by 2 matrix. And because they are the same dimensions, we are able to add them together. Okay, and the way we add them is simply by working out what is the corresponding element added up with each other. So in this case, this is the first row, first column. We add that with the first row, first column. So we have to add them with the corresponding elements. In this case, I'll use different shapes. We would add circle with circle, triangle with triangle, rectangle with rectangle, and star with star. So what is 3 plus 0? So 3 plus 0, that'll give us 3. 2 plus minus 3, that's the same as 2 minus 3, which is just minus 1. Minus 2 plus 4, that's the same as 2. And minus 2 plus 1, that's the same as minus 1. So this is what matrix A plus B is. Now let's have a look at question number 4. Question number 4 has multiple operations. We have to do both scalar multiple as well as a subtraction of two matrices. Let us first write down this entire statement in matrix form. If you were to write this question down in matrix form, here's what it would look like. So we would do 3 times matrix A, which in this case is 3 times 3, 2, negative 2, negative 2, plus, or in this case minus away 2 times matrix of B, which is 0, minus 3, 4, 1. So let us first scalar multiple, evaluate the scalar multiple of both of these matrices, for matrix 1, or matrix A I should say, and matrix B as well. So for matrix A, doing 3 times this matrix, that's just 3 times every element, which in this case is 9, 6, minus 6, minus 6. Minus away, if we do 2 times each element, that's the same as 0, and then negative 6, then negative, or in this case 8, and then 2. Now we just have to minus away two matrices. And it's very similar to adding two matrices in that all we do is we have to minus away the corresponding elements. Okay, so I'm representing each element and its corresponding element in shapes. So let us now work out these two matrices minused away from each other. 9 minus 0 is simply just 9. 9 minus minus 6, which trips up a lot of people. 9 minus minus 6 is the same as 9 plus 6, which is the same as 15. Minus 6 minus 8 is minus 14. And minus 6 minus 2 is the same as minus 8. And that is how, oh, I made a mistake here. It should be 6 minus minus 6, that should be 12. Now let's have a look at our next question. This next question doesn't deal with 2 by 2 matrices, so let us first work out what the dimensions of each of these matrices are. For matrix P, what I notice is I have 3 rows and 1 column. So if I have 3 rows and 1 column, this would be a 3 by 1 matrix. The next one also has Q, in this case Q, has 3 rows as well, but this time it has 2 columns. So this would be a 3 by 2 matrix. R has the same dimensions as matrix P, so I'm just going to say this is a 3 by 1, and the same logic can be applied for S. S has the exact same dimensions as matrix Q, so we can say that's a 3 by 2 matrix. So now let us work out the following questions. Question number 1. What is 2p plus r? Well, first let's write it out in matrix form. So this is 2 times matrix P, which is 3, 1, 2, plus the matrix of R, which is 4, 1, negative 7. Let us first evaluate the scalar multiple. So 2 times each of the elements in this matrix is just 6, 2, 4, plus the matrix of 4, 1, negative 7. All that's the same as is we just have to add up each corresponding element. 6 plus 4 is 10, 2 plus 1 is 3, and 4 plus negative 7 is the same as 4 take 7, which is minus 3. And that is the answer to question 1. Now let's have a look at question 2. Question 2 is asking us to work out what is the matrix of Q take away S. So let us work out Q minus away S. So matrix Q is 1, 4, 9, 3, negative 1, 4, minus 6, 1, 7, negative 2, negative 7, 1. We just have to minus away the corresponding elements. 1 minus 6 is minus 5. 4 minus 1 is 3. 9 minus 7 is 2. 3 minus minus 2 is the same as 3 plus 2, which is just 5. Minus 1 minus minus 7 is the same as minus 1 plus 7, which is equal to 6. And 4 minus 1 is 3. That is your answer to question 2. Next question, question 3. Quarter R plus a third P. What a long day. Quarter R plus a third of P. So in this case, what we can do is we can evaluate the scalar multiples for each of these. So what we can say is a quarter times by the first matrix is simply 1, a quarter, and minus 7 on 4. And for the next matrix, we just have to do a third of each of these elements. So that would be the same as 1, a third, and 2 on 3. So now we just have to add each of these matrices. When we add each of these matrices, we just have to add the corresponding elements. 1 plus 1 is 2. A quarter plus a third, you can do that very simply by just doing a quarter plus a third out by hand. This is the same as 3 on 12 plus 4 on 12. Okay, that's the same as 7 on 12, so 7 over 12. And then the last one, minus 7 on 4 plus 2 on 4, that's the same as minus 21 on 12 plus 8 on 12, sorry, which gives us minus 21 plus 8, which is minus 13. all over 12. And because this is a little bit ugly, like to have fractions inside a matrix, you can also just factorize out 1 over 12. So if I factorize out 1 over 12 from each of these elements, what I'll be left with is a 24, a 7, and then a minus 13. And that is your answer to question 3. And the last one is 2p plus q. 2p plus q, let's work this one out. 2 times p would be 2 times 3, 1, 2, plus the matrix of q, which is 1, 4, 9, 3, negative 1, 4. And if your answer to this is you're not allowed to add these two matrices together because they're a different size, you would be correct. You cannot add two matrices that are of different lengths or sides or columns, just in general. So it doesn't even matter what 2 times this matrix is, it'll still be a 3 by 1 matrix added with a 3 by 2 matrix. So question 4 does not even have a solution. Okay, so be very careful when you're doing arithmetic with matrices, but this is how basic arithmetic with matrices works.